Okay, guys, second stream of the day. Let me just reply to Wolf here and let me share the link as well. Check out the Windows posts. You'll find the language champion document there. Okay. Awesome. Okay, guys, let me quickly share the link. Stream. Day 14. Oh my God, 2 weeks. Let's go, guys. Let me just find the docs. Okay. Let's start. Let me open up the live chat here if anybody is writing anything. Generate multi. Let's continue with this one. So we ran and got some results. Let's see what the output was. VS Code examples. Okay, so here are the results here. We have to parse and analyze what happened exactly in the generate multi script. Okay, I have no idea what's the output here. Yes, Sergey. We actually already ran the evals. So we have the BLEU, we have the spBLEU, and we have this CHRF metric already computed. Give me just a second. Okay, so let's wrap up these tasks. So we're going to go through the eval, understand what went on, what happened, analyze the script, and let's also check what's this SPM tokenizer they mentioned in the paper. And potentially let's solve the bug, because in the previous stream I made a quick basically hack to get the eval to work. So let's see what of these tasks we want to focus on first. First, let's maybe go to section 811. Section 811. Just search 811. Here we are, training a tokenizer for languages. Okay, so when they said they were training, let me see, newly trained SPM tokenizer section for spBLEU course. Okay, so I guess they were just mentioning the SPM 200 model for the for the scores. Okay, let me just double check that. Training a tokenizer for 200 plus languages. Yes, that's the one. We trained a new sentence piece tokenizer. We went through this already. To evaluate with spBLEU, we use this SPM200 as a tokenized to better support the languages of Flores. We open source this sentence piece model along with the Flores dataset. Okay. So this part is actually clear. Let's focus on the results. First sec generate multi. So this was the one we were running. I kind of hacked it such that we can get it to work by modifying the logic here. Do I know Hindi? I don't, Pranav, I don't speak Hindi. That's why I'm using help from people from the server to figure out what's going on. Let me see, array run. Okay, so we ran this. What I want to do, I want to compare the output of this one with the interactive script. Let me just see what are the differences between this one and the interactive script we ran before. I want to make sure we have the same types of arguments here. And then we ran all of these different spBLEU scripts to get the results. Okay, let's go here. Let me hit F5. No arguments, that's good. Let's run this. Just on the light. What is going on? Why is this not running? Aha, because I guess we already have the results, so it doesn't want to override the results, which are here. Generate the output, no cap. Okay, let's just rename this to like old, and let's rerun it now. I assume that was the reason it was not kicking off the run immediately. Okay, so let's see what we get here. Debug console, languages. Let me quickly contrast this with what we have in the launch JSON, VS Code launch JSON, interactive. So we have the input, which is a file. We pass in the dictionaries, the model, the task, the languages. Let's see whether there is any significant difference here. Just, hey Gordon, currently training on my local rig, basically 2 RTX 3090, but we'll soon start getting some compute. For now, there is still some job left for us to get this running end to end, and then we're gonna focus on getting compute. Well, in parallel, we should start doing it, of course, just to avoid being blocked by waiting for compute. Okay. So here we pass in the model. Oh no, this is, you can definitely contribute, man. Let me show you. So we have a channel here called OpenNLLB on Discord. There is already a ton of contributors, people helping around various things, even translation. And check out, we have this document for language champions if you want to help with data. We also have getting started guide here. That's probably the best place to start. Just open up the getting started document here, and you're gonna see everything you can do to contribute. Let me paste this one to the chat here. You can check it out. So there is a ton of ways you can contribute and help and just collaborate with us. Okay, so data and then path to the model checkpoint and then task translation, okay, and then languages. and then the pairs, and then the source and the target, encoder, validation, beam, BPE sentence piece, and then the model, and then spBLEU. Okay, what I want to do is grab this, copy it, quickly paste it here, so I can compare it with what we have been passing to interactive script here. So I'm gonna just put it like this, okay, and then start deleting piece after piece. So the first one is data. We can delete this. I'm just trying to contrast and see what's the diff by doing this. So we already passed in the model, so that's good. We have the task, which is the same task, translation multi-simple epoch. We have a ton of languages. This might take a while to delete all of them. This live series seems fun. Do you have a set timing for it? I do, with some small variations. I can share with you the schedule. It's based on Central European time because that's where I'm at. 10:30 a.m. is roughly when I start, mostly around 11 actually, and then it goes until 3 or 3:30 p.m. and then the next section is after half an hour, like 4:30 p.m. depends, going until 6:30 p.m. and then afterwards 8:30 to midnight basically. But like keep an eye on the channel, and then you'll always find the latest streams in the Discord. Okay, a couple more languages to delete here. This was painful. Let me just delete all of these. Okay, and then we have the language pairs. Okay, so same thing here, and then source language, source lang, and target lang. Okay, and then encoder lang token. This is the same, and then we decoder. Okay, this is also the same. Let's just remove all of that. So far it seems we passed in all of this. We didn't pass the dictionaries. We did pass this. We didn't pass valid because it's a bit different format. Beam, BP sentence piece model, looking good. And then add data prefix tags, all good here. And then spBLEU enable, okay, looking good. I think we have equivalent runs here. And then results path goes to here. Wait, let me see here quickly. Results path goes to the checkpoint best valid under the generate output no cap. Let me find that. Here it is. Okay. Best valid. And then we pipe that. So that's the result path. And then we pipe that into no cap eval out. Okay. Looks pretty much the same. Would be cool to run generate ones directly just to make sure it makes sense. Let me open up the generate script. So we are here in generate multi. We want to go to farsec CLI to generate script. Here it is. Yeah, no worries, Pranav. Let's see how this one is going to work. process stop predictions, main. Let's just run it once directly, because then we'll be able to decouple generation from evaluations, and I just want to get some familiarity with this code base as well. That's why I'm basically taking a bit more time than what is really needed. So to go here, I'll actually have to grab this command, and let me see what this does. BLEU command, blah 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 blah. Full command is generate command, followed by the post process command, followed by BLEU. Okay, so these are the evals, and these two, let me just see how this, what does this one do? Okay. Pipes it to eval out. I assume this means pipe this to pipe fail here, and then okay, let's just run this. I need these arguments minus the last ones here. Copy. Let's go to generate. It might be the same script here, by the way, guys. So we can just do paste again here, grab the path, change this one to the new one, grab the path and just paste in the latest model. This is the one that we care about. Task remains the same. For languages, let's just grab all of these. What's going to be the easiest way to just take the languages? Whoops. Here we are. Just something like this. Paste it here. Put a comma. Yeah, we're done. Lang pairs, what we care about for now, let's put maybe Turkish. Okay. This remains the same, English, and then this should be Turkish. Or let's go with Hindi. Hindi Deva. That's the script. Source language, target language specified. Encoder, decoder. Valid. Beam we can set to 5. BP we can set to sentence piece. Sentence model. Let's set this one. ChrBLEU, enable, we can delete these now. This is all the same. This is all the same. Results path. Looks like results path should be a directory, not a file like here. You're gonna see that in a second how this is used. Okay. And let's run. So that's generate. The only thing that will differ for the next loop is gonna be the languages, right? Everything else remains the same. So we're gonna have Turkish here instead, Turkish here instead. Everything else remains completely the same, because between the iterations here in the loop, let me just find again the generate multi, here it is. In this loop, the only thing that changes is the lang pair. Which means source and target. Source and target changes, and as a result, this output directory also changes. And that's it. Looking good. Almost. We need to replace this. This should not be Turkish, this should be Hindi. Eval. Okay. Save. Open the generate method. Versec generate. Specify the generate and run. Step by step, we're going to understand how our evaluation works. Whoops, why do we have... Aha. I started both of these. We don't need this one. Let's just go back here. Okay. Run. Import user module. What does this one do? Tries and finds the user directory, which we don't have. Okay. So you can just ignore that. If this is none and batch size is none, then we set max tokens to 12,000. Interesting. This is 512 for us, right? Batch size. Max token should be, actually, let me see. Batch size is 50, that's fine. Okay, let's go. Set some seeds. Set up the task, that's the usual stuff. We have this in the training loop as well. We can skip over all of that. Then get the source dictionary. Get the target dictionary. Okay, load the model from this particular path with no overrides for this task. Checkpoint suffix, shard count 1. Sounds good, let's just load the model. Okay, after that, load the validation dataset. So let me just quickly dig into this to make sure we are loading only this particular direction. Just see whether I understood the logic correctly. Why am I? Okay, here we are. Load dataset. For splits, we go here. We go and load the dataset. Okay. We go inside of here. Let me quickly enter here as well. Let me just make sure this makes sense. Key data path is going to be what? This one. Validation, source. Looking good. Let's go here. Let's enter and load this data set. Just make sure this makes sense. We should go all the way to here, I guess. Yes. And then we load from this dataset path. For this split, we find the languages. How does it find? That's the part that interests me. So I'm gonna hit F5 here. Okay, directions. There are just so many additional calls here. If the split exists, then we format. Prefix source looking good. Validation, followed by the prefix English, Latin, Hind, Eva, and then we're looking for. I think that's the right prefix. Let's just double check. If we go to stopes quickly, in the stopes we have process data new, we have the data bin, we have shard 0, and then inside here, that's precisely the format that we are looking for. Valid, and then direction, and then the actual name, okay? With the source and implementation is nothing here. Max source positions. This should be set to 512 actually. Truncate source. This should be set to 512. For some reason, we did not set that. Let's see what it does. Grabs the full path. Will it know to add the bin? Turkish. Yes, Turkish is supported. Load the indexed data. Again, let's just enter here the path. Get the local path, local index path, okay. Local data path, okay. Exactly. And the local path is this. Yes. That worked nicely. Infer the implementation. And that's the right implementation. And then we say make the dataset with the right implementation. It enters here, goes inside here. Haha, nice. The path looks like this. We grab the index to build the index, and then for the bin, we grab this one. Okay, all of this will work. We can exit now safely. Just exit, exit from here as well. Exit. We can safely exit from here. Now I'm not sure why this was set to 1024 when in reality we need 512. Okay, this is again cast in above. Let's just see why max source positions, why is this specified as 1024? Let's exit here. Where do we specify that one? Here, 1024. Max source position from the arguments. Max source positions from the arguments. If we go we go to our training, I think, oops, let's just make this from underscore to dash so that we can find it in our config. Here it is. As you can see, it's always set to 512. It's set to 512, yet for some reason we set it to well, I guess because during the training we want to basically constrain the context length, thus the memory and all of that. But here during inference, even if it goes past 512, if you have enough memory, you can do it. It's not going to be perfect, but yeah, I think this is okay. This is okay. So exit from here. We've successfully loaded the data sets. Hit F5, get here. We have the data set for the hint deva. We can exit here as well. Exit here as well. Looking good. And we are back to the main generate. We loaded the dataset successfully. And now we go through the models and LLMs, which are none. We push the model to the GPU. We prepare it for inference. And then load the line dictionary like that, with the replace unknown set to none. Empty if no path. Okay. World size is gonna be 1. Oh, fun. That's set to 1. Okay. And then get the batch iterator. Max tokens set to none. Number of sentences is set. Validation. Let's see what this will give us. This particular line. What do we get from it? 512, 512. Okay, actually max positions for the iterator are set as 512. Skip invalid size inputs. Set to false. Don't ignore. Common seed, number of shards. Data buffer size. Okay, looking good. Progress bar. We can just continue here. Build the generator. Okay, I'm not sure what this one does. Build the tokenizer, build the BPE, given the sentence piece model is here. Okay, let's maybe quickly see what these two do. Build generator and build BPE, and then build scorer, and then we're just going to start it generating the results. Okay. Let's enter here. Here is the build generator. Okay, it just calls into build generator of the superclass, and import some stuff here. Continue, continue, continue. If some raise, some error checks, constrain, blah blah blah. We just keep on going up there. Target dictionary beam search. Sequence generator with the model, with the beam search, and then get max length This is gonna be what? 0. This is gonna be what? 200. Minimum length 1. Normalized scores. Length penalty. So this is just specifying the sampling options. I assume this is, I'm not sure what's length A and B. Unknown penalty, temperature, extra keyword arguments. Okay, symbols to strip from output. Let's just enter into this. Enter. Sequence generator. Under sequence generators, under fairsec. Okay, ensemble model. Vocab size, that's the right number. Max length. None. Beam size, if it's okay, we just return the search strategy. Should set source length, set the model to eval, and that's it. And then in the forward, they call the generate, which does, okay, we just features, batch size, beam size, and then start sampling. Okay, I can't go into all of those details now, it doesn't even matter. Okay, so that's the generator. And then the tokenizer, let me just check this BPE one quickly. Build the BPE. What's the name here? Sentence piece. We get the data class, merge with parent, class, build, sentence piece BPE, enable sampling, set to false, alpha, grab the cached path, here's the model, and then we just load from there. Okay, that's it. We are back to the top level. There's the build scoring function. So currently we have what? Name BLEU, pad EOS unknown. Okay. Build the score as a BLEU. Why is that set to such a value? Why do we even care about BLEU here? Because later we're gonna call ChrF BLEU either way. I don't think we care about this one as much. Okay, and then for sample, we start iterating through our data set, which is basically florist sentences. Here they are. I mean, if we are really, let me see what we can do here. Do we have the tokenizer? Yes, we did. No, we don't. It's none. But BPE is a sentence. Let me see what this BPE has as functions. So BPE, we just do string of BPE so we can see all the functions it exposes. It's API, if you will. Decode, encode. Okay, fair enough. Let's try and see what the decode does, because we have here a sample. I just want to make sure this is the right sentence. Like it's the same, it's the first sentence in the Flores dataset. So let's grab the net input, and then let's go grab the source tokens. And now we want to pass this into BPE decode and see whether that works. Okay, not really. So what does the decode do? How do we go back from tokenized, from this representation to text? Decode, encode is beginning of word. Let's see what encode does. So if we were to do encode, hi there. Aha, okay. So we have to use, I guess, the vocab. Where is the dictionary here? Target dictionary. Do we have a source dictionary? We do have it. Let's see what it has as the output here. Let's see which methods it offers. Okay, it offers a lot of functions. Add file to dictionary, add from file, add symbol, BOS, dummy, encode a line. Do we have anything like decode, indices, pad, symbols, unknown, update? Source, dictionary. Okay, so if we were to go through this, let's convert quickly samples to temporary. It's going to be equal to this. And then convert to numpy. So TMP equals this. This is type tensor, I assume. Yes, let's just convert import numpy as MP and then convert to MP as array TMP. That's the TMP now. And now, what's the shape? Okay, let's grab the first one. Let's grab just the first one. 4817. If we grab the first sentence. Okay, and now let's go through the this is going to be like this. We go through elements in temporary and we call source dict of that element and we get something. Let's see what. Turkish Airlines flies to 3 to 9 destinations in 30 African countries. Okay, so we got that one. We managed to detokenize, to decode. Now the problem is we are obviously shuffling. This is not the first sentence. Why is it not deterministic? I don't know. But it doesn't even matter for now. Okay. Prefix size. Now there's the inference step. So we pass in the generator, the model, the sample, the prefix tokens, which are none for now, and then we do the inference. So let's see. I think we can just go and let it do its job until we get the hypothesis, which there are 48, and then for each one of them we have 5 because we have beam 5. Okay. And then go through the hypothesis, sum the number of tokens, that many, and then go through the sample ID to list. Let's see what we're trying to do here. Not completely clear. Step through this. If source tokens exists. No, I just saw the comment from Shrutaman. No worries, man. Strip the pad. to get the pure source tokens. Strip the pad here to get the target tokens. Okay. Post process, nothing is set there. Aha. So here's how we get a string. Okay. Turkish Airlines flies to blah blah blah. Oh, nice. This is actually, we got the idea of this sentence. It's 954. Got it. So if we went to Flores here, if we go to data, eval, Flores def, let's go, for example, Turkish, because that's what we're doing. If we went to, what was the number? 958, I think. Or no, 954. Here it is. 955 is Turkish Airlines flies to 39 destinations. That's the sentence we found, right? And it's 955 because it's different indexing. Here we start with indexing 1. They start with 0. So that's it. That's how we found that sentence. So if it has a target, let's see if it has a target. Then we do what? Convert to string the target tokens, which we got by calling the sample. So what did we do with hypothesis here? No idea. Let's just see what the target is. Oh, okay. Okay, yeah. For target, we obviously, because we're dealing with Flores, he's just gonna grab the ground truth here. So this is the target string. The ground truth is this one. Why are we dealing with Hindi or with Turkish? I think I swapped it to Hindi at the last moment. Yeah, we're actually dealing with Hindi here. Okay. And then decode function to give us the actual sentence, and this is the language token, and we decode this, and if it's not quiet, we print to the output file, which is where? Which is under here, generate valid text. Let's quickly find that under model checkpoints, under this one, Hindeva, generate valid. So we just wrote down source and then index and then the sentence with the token. And here is the ground truth. Okay. So let's go. We're trying to find the best one only. Here it is. And then we post process. We first grab the tokens, convert to int CPU. Here's the source string. Alignment is empty. This is also none. Target dict. This is none as well. Get symbols from, strip symbols from output that we need to ignore, and then post process. Why are we passing for hypothesis? Why are we passing source? Is there anything fuzzy going on there? Let me just go here. Convert this to the hypothesis. Here it is. And then we just retrieve it back. That's it. And then we decode it, and here it is. And now we go and find the score. And the score what is the score exactly? I guess for beam, for this particular hypothesis, some sort of, probably a probability for that particular hypothesis. Okay. And then the tokenized one. Okay. And then, so here we're now seeing the format of this file. We're now seeing the format, which is, as you can see here, actual sentences from the Flores, and then actual hypothesis, and then decoded, but this is like tokenized still, and then decoded. Okay, and let's see what else. Okay, and then at the end, positional scores. We do what with them? We divide by log2 to convert to a list, then we format them, then we join them, and then why do we need sample ID here? Because, okay, because that's gonna put us P sample ID tab, and then finally positional scores. We go here and we end up with this one. So these were scores while we were doing the beam sampling, I assume. Okay. And then we do what? If it has target, nothing there. And then we do to the scorer, we add the target tokens and the hypo tokens. Fair enough. And then the scorer can basically do its magic. And this is BLEU, right? Shouldn't BLEU work on like directly on text instead of tokenized sentences? I don't know. Okay, but that's it. We're done there. Now we go for the now we're going for the next sample in the list. Let me just see for a second. So sample progress, sample ID has how many elements? I guess 48. Data. Let's see, sample ID to list. And what's the length of that thing? I guess 48. 48. Why 48, by the way, guys? Why is it not 50? Because 50 is the number of sentences we've set. That's a bit of a confusing part for me here. Run this, and we get to here, which is basically first sample has been processed. Number of generated tokens is that big. So this is kind of words per second meter. And then we log. And then number of sentences is we go through the samples. Okay. And then we just keep on doing this, guys. And that's it. So here now in this validation, we'll have a ton of different. Well, how many do we expect? We expect to see 5 per sample, and we had 48, so that's what? 240, right? Lines. Yes. So that's how this output file works. Let us just remove this breakpoint, let it do its job. You can see the progress here because we have this JSON bar progress. Okay. almost done, almost done. Again, the part that's confusing, let me put the breakpoint before it stops. Please, 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 no. Okay, let's see, what's the... Okay, I literally caught the last one. It has 5 sentences. Anyway, we hit F5. That one is now ready. I want to check why we are 997. Okay, that's the actual number of lines, if I recall correctly, in Flores. So if we go here, indexing from 1 to 997 exactly, okay. How did it choose to not to pick 50 immediately? That's interesting. Translated 997 sentences in 67 seconds. It has target. Then we do what? Generate, what's the output file? Is it the same one? Generate valid. Okay, let's open it up. Why am I closing it down every time? Generate valid with beam 5. Aha. Okay, here are some results. BLEU 4, 16, 64, 46.6, 23.2, 12.9. Ratio, sys length. I have no idea what this means. I guess BLEU 4 stands for some 4 numbers. And then there is 1, and then 1, 2, 3, 4. Not completely sure, but either way, we're not doing eval with this scorer. We have a ChrF BLEU that we are using. And that's it. This one returns back the scorer. And we are done here, right? That's it. Okay, we saw how the generate function works. That's cool. The confusing bit was, why did it choose only 48 sentences initially instead of 50? What was the logic there? I would expect to just go 50-50 all the way until the end and then just take the rest. Let's quickly rerun. It will probably stop. Let me see. Oops. I just remove all of these breakpoints we've placed before and get to sample. F5. Okay, here we are. So first let's quickly see whether it's consistent. 48, it is. Let's go hit F5. Let's see again. 48. Why? Like, aren't we using exactly 50 here? Could that be a bug or just a feature? Let's enter here. Data loader. Next data. Get the data. Return the data. What's data? 48. So here is where the annoying thing happens. So let's understand why. Let's hit it next time as well. Okay, let's enter here. Try and get the data. Data queue. Data queue get. And again, it's gonna be 48 or what? 48. So it happens here in the data queue. So this is a bit above. Let me think here. Why? Progress is just wrapped iterator. Let's see what is specified here. Maybe because of max tokens. But then 48 every time sounds also weird. Okay. Valid. None. 50 is the batch size. Max positions is just 512. Ignore required. Aha! Required batch size multiple. Okay. Got it. So 6 times 8. So it's like this is the max number. We go max, but like it needs to also be divisible by 8. Okay, whatever. That's weird. I guess some optimization detail on their side. Okay, we can now safely stop this. So ultimately what happens is they write using the print statement here to the output file, which is specified where. Okay, so we directly pass in the output file to the main. Just a second. Okay. Config. Aha. The reason I'm looking into this is because we will ultimately be calling this generate multi. And I'm just trying to see how it works here. Because it's piping the results to the next stages afterwards. So results path, if it's not none, and it's not, then we make the directory there. Okay, makes sense. And then we create the output path by what? Combining that with generate, and then depending on the subset, and rank suffix, which is empty. Okay. So that's how they call it. And then they open up the file, and then they pass in the handle to the file. Okay. And then at the end of this function, what do? We just log and return the score. Okay, so let's now go back to the generate multi, because we've seen this makes sense, this works properly. Generate multi is here. So the output here is then sent to eval out in the same directory, and then we do this. Sentences are tokenized prior to compute. Are they? Okay, I didn't know that. So that's why they say it depends on the tokenizer. So that means every BLEU score might be different depending on the type of tokenizer you're using, right? That's why they make sure we are all using the same tokenizer. Anybody knows what this does? So once we run this Python, we do this. Looks like some piping to eval out, but like, let me just ask ChatGPT what it exactly does. Full command. We run that full command. Subprocess run. Thanks, Sergey. Let's see. Full command. Okay, so this redirects the standard output of the Python script to a file named eval out in the directory specified by the output director. Appends the output to the file if it already exists, or creates the file if it does not. Redirects the standard error file descriptor 2 to the same location as the standard output. In other words, both standard output and standard input will be appended to the eval out file. Nice. This is like perfect use case for ChatGPT. Okay, awesome. But like, what was when we were running this code, when we were running generate, why are they even attempting to, why do they care about standard input, standard output and error output? Why not just reuse the generate validate, the generate valid txt file that we created? So here it starts writing stuff here. They do this basic config. Let's stream output file as well. Interesting. Generate multi. Let me find it. Okay, just run, and we're done. Okay. Fair enough. Okay. And then they call the bin bash. Aha, okay, so they here, okay. So that's just for additional, they're literally redirecting the standard output and the, got it, and the standard error there, and that's completely independent from the next command where they do the cat of the content we just generated, and then they process it. So let's see what this processing exactly does. So they process it, and then they can call the ChrF. So let's see what it exactly does. Let's go back to ChatGPT. What does the following bash command do? Well, not really bash command. Let's see whether it's smart enough. I think it's gonna be decent, if not perfect. Okay, let's go step by step. So grep takes what? After the cat command, the output is piped into grep, which is used to search for lines that start with D. And that's, if you remember, D was the de-tokenized sampled sentence. So if we open up here, if we open up this, D is the, let's just go above, D is actually the final sampled sentence. Okay. The A option tells grep to treat the input as text. And the P option enables Perl compatible regular expressions. And then this matches lines that start with D. Okay. The output from grep is then piped into the sort command. Tells sort to perform a numerical reverse order. Sorting should be based on the character starting from the second to the second character of the first field. Okay, so we can have D, and then they grab the number, source the line in descending order based on the values that follow D. Okay, and then the sorted output is piped into the cut command, which is used to extract fields from each line. Specifies that we want to keep only the third field. So that means we disregard the, I guess we disregard the score and this column here. So we only get the text. Got it? And finally, piped into streaming editor, a stream editor, used to replace any occurrence of mine data at the beginning of each line with an empty string. Do we actually have such a line? No, we don't, but I think this is the reason being is the way they train it. Sometimes they tag the data, so it might be, yeah. And then finally this gets piped here. Wow, guys, this was such a great use case of ChatGPT. Loved it. So that's what happens here. And then finally, once we have that, we run the BLEU, the ChrF, and ChrF. format text, ref file, here's the reference file, and here is the actual output. And we call tokenizer SPM, and then compute and pipe that into, okay, so we call again ChrF do this and pipe the results. Makes sense? Here we do ChrF with a different metric. We specify 2 here, and same. And then finally, tokenizer should be, if target is Chinese hands, which is simplified Chinese, I think, then say ZH, otherwise say INTL. Okay, and then save into the ChrF results. Cool. So that's how this whole thing works. Might be cool to actually see how ChrF works. For now, let's rerun this line. Let me pick the generate multi. Which one did we use for this one? How did we run it? Do we just specify? Yeah, we just specify the through the config. So we just specified this, and we specified all of these ones here. So example, this is good, this is good, this is good. Non-florist, is this one even used? I think that's the only one that's confusing. Non-florist path is only used if the data label is set, which it's not. So we can ignore it. And then let me just again quickly compare these two. So we have these two configs. We based off of this one, and we modified just the stuff we need. So local, custom, pool, all this is good. Root, model directory, eval on all, 10, valid source tense, true. Add data source prefix tags. Okay. Cluster is going to be example, as we saw before. Population of lead. We override the lang config and the model config and the launcher. We set these. We modified this. Checkpoints as well, right? Language pair per job, I think we've set it to 10 here. Data. SPM model. Okay, all is looking good. We could have set a different output directory. Just because, why would we output data to where our checkpoints are? Let's rerun. So here we go with no args. Let's rerun it again. We'll probably end up having no output because we already computed some stuff. Let me see. We already have this, so it might just end immediately. Here it is. It's running for this one. For the English, the Turkish. Gave up on this one. So this is just basically standard out and error. This is the actual command we ran, and this is the final result. And then it uses this one, pipes it into the ChrF, and to dump the final file once it's done. Okay, here it is. Here are the results. Generate best output. Is best output is the sampled sentences we have for all of the file, for all the 997 lines. Okay. Let me see where it's complaining something here. I don't see anything. ChrF output says tokenizer SPM has been changed to Flores 101 and may be removed in the future. That's 100 lines that end in a tokenized period. It looks like you forgot to detokenize your test data, which may hurt your score. If you insist your data is detokenized or don't care, you can suppress this message with force. Okay. So that's it. Today we managed to run already, to load the checkpoints that we trained last night, to create some qualitative outputs, and also now to enable running on Flores 202. I'm just wondering, where is the... We should have one more file, right? We should have one more file because we need ChrF results. I don't see the ChrF results anywhere. Or am I missing something out here? Blue, this is just the output. This one failed for some reason, apparently. Let's try and rerun the whole thing, because this one skipped. Actually did not. It ran as well, but ChrF did not run. Okay, it seems like ChrF utilizes BLEU but has extra standardization built in. Yes, Sergey, that's how I understand it as well. That's why they're using ChrF instead of spBLEU instead of BLEU. I don't know the exact details, obviously. Let's just try and rerun this. We can also run ChrF directly. That's what I want to do. You don't have to call it by command line. You can also just call it through their API. Here, and then corpus BLEU, hypothesis, references, and score. If metric BLEU, otherwise corpus there. Let's see how else it's used. Usually corpus BLEU. What's corpus TER? Computes TER. Where is this BLEU installed from? Just quickly see whether is there any mention of SPM? Or Flores? Flores 101 and Flores 200 uses a sentence speech model built from dataset respectively. The canonical SPM file will be automatically fetched if not found locally. How does it even know where we are? Okay. Or I think we have to specify Flores 200. Okay. Let's see the results now. Okay, so definitely something is not all right with spBLEU fails apparently, or something silently. We get this and we get the BLEU, but we don't get the spBLEU. Okay, so name we get 33.4, which I don't think is a good number for English to Turkish. Signature, case mix, TEFF, I have no idea what these are. NW space no version. Case mixed. Okay, and here for BLEU we get version. We get what? 8.6 and then some 4 numbers. Okay. That's for Turkish. And then for Hindi, we get apparently a bit better results here with Hindi than for Turkish. Okay, even though we have more Turkish text, but we upsampled Hindi. And then 37.2. Fun. Let's see how we can call it directly. Compute BLEU. Is there any other way they're calling it? ChrF BLEU tokenize ZH. Interesting. let's try and kick it off with setting instead of SPM, setting something else. So setting I think Flores 200 instead of Flores 101. Okay, I think that's what they mentioned in this readme here, right? The one we saw before. They mentioned Flores 200 to use this one. So let's do that. Let's put it like that. Here I have no idea what's INTL. Let's check. What's INTL? Applies international tokenization and mimics from Moses. Silent failure. Okay, that's kind of indicative of what we've seen. Sequence of reference documents. Okay. Let's try and rerun this with Flores 200, and then we're gonna just call it through Python directly. I think that's better. Let's do that. Call generate multi again, and just change this again to run. Will we get any different results? I don't know, we'll see. Okay, it seems it's gonna be equivalent. I think it always uses Flores 200. Here it uses a bit different. And then tokenizer BLEU. Downloading. Okay, so it seems it's using a different model. It says it's downloading the SPM model to this location. Interesting. Let's see. This is probably Moses 13a. Okay. We can step through this ourselves. Okay, this is not Python. We forgot to call the tabulate function that we commented out as well. Okay, here's some implementations directly here under Fairsex scoring. Okay, let me see the results. Are there any different? Let's compare them. Let's grab BLEU here and let's open up. So that's English, Hindi, BLEU, English, Hindi, BLEU as well. Let's open it up here. Is it any different? The result here versus this one. Okay, 15.7, 40, 40.7, 22.6, 12.4, 6.9. It's even worse. Haha, so the older one actually gives us better results. Okay. So now if we were good researchers, we would pick the better one, right? That's how they do it. Let's see this metric, English Hindi and English Hindi as well. Let's put it here. This is the same, 37.2. And what about Turkish? Let's pick BLEU here and let's pick BLEU here as well. For Turkish, we pick the better one with, you can see that, right, we improve the model by, exactly. By just running a different token, by just running a different tool, we got better results. 8.6. So for Turkish, it seems we got better. We got better results for Turkish. Interesting. Let's see the other metric, and here as well. And these are the same. So apparently, this one doesn't probably even use SPM 200 in the background. I'm not sure how this one is computed. Okay. Fair enough. Let me close down these files. Close down this one. Get the generate multi and uncomment this second one. Let me just see what this function does. There was this, wait, the generate multi opened up, find the tabulate. So you see before here this was called this tabulate one. I'm not sure what it did. It went through the checkpoints, and it went through the splits, and then it did what? It went through the language pairs. Found the results here. probably just parsed them out. Yes. As well here. And then command. Check the output. Okay, and then get the averages. And then put, so for some reason, as you can see here, they also just print out BLEU and this, as if they don't, as if they're also not getting the final, the spBLEU. So open it up and then run. Okay, let's try and run this. Exactly. Comment out this one and see what we get. Let's run. Will this fail? Of course it will fail. Get the type. We are now under evaluation. Okay, just run it like this. It's gonna fail here as well now. Okay. And see whether this works or we fail here. Not sure what this is. Whoops, did it work? Did it actually work? Okay, output directory, no cap, and then the TSV file. Let's see. Excuse me. Okay, so it gives us this and it gives us this. Okay. English, all high, English, Latin, Hindu, Deva, for BLEU. And then for this one, additional stuff. Okay. So you just prints stuff here. Okay. We can stop it. We are done there. The final thing, I just want to quickly understand how this works. ChrF how are you actually being run? ChrF score. These are just called like this, translation, compute BLEU, corpus BLEU. Okay, so here's this one. So they have a couple of these underscoring. They have a couple of these files, underscoring. All of them are underscoring. Underscoring. Okay. Where is my custom function I wrote? It was somewhere here. Calculate custom. Let's find the scoring. Where did they save that? Sweeps. Is it under fairsec and then scoring? Data distributed scoring. Here it is. So they have tokenizer, BLEU. Why are we then calling Meteor bird score, base score, string score, result string, just an abstract class there. Build scorer by calling the BLEU scorer with the BLEU config. And import BLEU from where? From fairsec scoring. Let me see what exactly they do here. So they, I assume, import ChrF somewhere. BLEU stat, ChrF tokenizer. Default is 13A, I guess Moses. Apply lower casing. Level. Okay. Evaluation tokenizer. Add the string. Score calls ChrF corpus BLEU with all of these. With the particular order. Okay. What does this one do? Does anybody mention this one? I want to just quickly step into any of these. So it's defined here and it's used in a couple of locations, like here with the arguments. And then they just call it like scorer, add string. Okay. What about this one? It's also base scorer. And then score like this. Meteor. NLTK. And then scoring is basically calling NLTK meteor score. We don't care about this one. Let's bird score. Bird score. Okay, probably some neural method as well. Tokenizer. A generic evaluation time tokenizer, which leverages built-in tokenizers in ChrF. Additionally provides lowercasing, punctuation removal, and character tokenization, which are applied after ChrF tokenization. Is this one used anywhere? Evaluation tokenizer. So it's used in BLEU and here as well. I want to see this one next. Word error rate. We try and import edit distance. Okay, so what I want to do now is just quickly create a file that uses BLEU and CHRF. So calculate metrics, custom, well, why not just directly create a file here? Okay, so I'm going to create a temporary file here. So temporary file, and then import. First, let's start with this one. Import from ChrF, import this one, and then we have to instantiate it and just say score. Let's see, score like this. Where is this one called? Here and here. Nobody uses this one, okay? And then no, actually just score 2 sentences, or score for score you cannot, you just first have to add a string, and then okay, and then you can call the result string. With the order and call the score. Okay, let's see the result string. Result string, and let's print this one. Will this work? Let's see. Run. Whoops. What? Bro, ultimately this just calls this. There's no way, there's no reason to import anything really. Import spBLEU, and then spBLEU corpus, blah blah blah. Prediction is this is a test, and here we say this is a test. Okay, let's go. Enter. Computes for corpus against a single or multiple references. If this is equal to, the metric is referred to as CHRF plus, a sequence of hypothesis strings, a sequence of reference documents, with document being defined as a sequence of reference strings. Character engram order, word order. Determine the importance of recall word versus precision. Set to 2. epsilon smoothing. Applies epsilon smoothing similar to reference. Otherwise, it takes into account effective match order, similar to spBLEU, smaller than 2.0. Okay, there's just a ton of settings here apparently. Did we set order anywhere? I don't think so. Okay, let's just go back to where the cursor is. Okay, this is set to 0. We need to put 2 here. So let's just put okay. Put this to 2 and rerun. Let's enter. Here we are. Create this class by setting all of these. If reference is not none, okay, and then corpus score. Check corpus score arguments. Okay, extract corpus statistics. Cache references. What this one does is pre-process the segment to lower. If this is set to lower, it's false. And then extract the referencing. Go there, extract all character engrams. Line. We split it and then we join it. Just grabs the engrams. Removes the punctuation. Stats. Why do we have T1? Something is off here. This is a test. It should be a sequence of strings. Okay. So that's our mistake again. Hypotheses are sequence of strings, and these other ones are. So this should be like this, and this one should be like this. As far as I understood this now. Okay, let's stop it. Let's rerun quickly. Looking good now. Extract the corpus statistics, cache. Grab the lines. This is a test. Add the line. Process the lines. Extract the statistics here. Okay. How many single letter engrams? 2, 3, 4, 5, and 6. All different engrams. If it's bigger than 0, which it is, then we remove the punctuation from the reference, and then extract the word engrams, append to statistics. Okay, and now we are done. Okay, process the segment. The reason I'm doing this is just to understand whether they're using SPM anywhere. They're probably using an SPM for BLEU, but not here. Compute segment statistics. That's why we didn't have any variation when we ran with Flores 200 setting. Okay, so everything is falling into place. Compute segment statistics. Again, extract all the engrams. Blah 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 blah. I don't care about the actual details of how this exactly works even. Exit here. What I care about is understanding token count 0. Okay. Looking good. Actual score 100. Nice. Nice. Okay. So let's just quickly do one thing. Let's quickly iterate through, confirm this works perfectly the same as when we ran it via the command line. So if we go and open up the Turkish output, let's find the, close this down. We're in VRSec. I'm trying to find the output from generate multi, exactly. Where does it output? What's the output directory again? Oh my god. What's the output directory? The output directory is multi-full. Where do we specify output? Wait, I think it's in here, and then output directory, model directory. Okay, so where is the model checkpoints? Where did I lose you? Okay, here you are. Here, exactly. And then open up this one. Okay, so we don't care about results or this, we just care about this. Okay, so let's grab this one and make sure this translation is what I think it is. Is it? I just need to make sure these are ordered in the same way as the original Flores. Google Translate, go from Hindi. Okay, makes sense. So they are in the right order. So I just grab this one. This is the Hindi Deva result, which is the output of the generate script plus some processing. And then I copy the path to this one. And then I find my script here. So here is the Hindi empty path. Okay, here it is. And then Hindi ground truth path. The ground truth is under Flores. Exactly. Eval datasets. Flores 202 dev. And then this one. Okay, this is the ground truth, I think. Unless Copilot messed up something. So now that we have these two files, we can go and compare them using corpus CHRF with word order 2, which should work perfectly. Quickly opening up Gemini Multi. And seeing how they call it here. Okay. So Flores. Do you even care about... Okay, this makes sense, but I'm not sure we care about tokenizer here. Yeah, because I'm fairly sure that CHRF does not use go with spBLEU here. Okay, major downside of BLEU is that it is tokenization dependent. Efforts such as this one have taken strides towards standardization, supporting utilizing community standard tokenizers under the hood. However, these tokenizers do not extend to many languages. Based on standardized SP covering 100 languages, released with Flores 101. This work will provide SPM 200 along with Flores 200 to enable measurement of spBLEU. Okay. So these are just kind of standardized. BLEU overcomes the limitation of the BLEU score, which requires that the sentence can be broken up into words. However, some languages such as Chinese or Thai do not use spaces. There is also concern about highly agglutinative languages where BLEU fails to assign any credit to morphological variants. Overcomes this weakness by basing the overlap calculation on character level n-grams, F score, and complementing with word unigrams and bigrams. So this one does not use tokenizers at all. That's the thing, to the best of my understanding. Okay guys, so I think I figured it out. We are actually using spBLEU. So the blue here is actually the spBLEU. So these scores here are actually blue, because we're using Flores 200. So we got the spBLEU and the CHRF plus. Okay, that's my understanding. Let's go back here. calculate metrics, go to the custom. It's not what I'm looking for. Okay, that's what I'm looking for. Temporary. Let's go here. Let's compute this. So we open up TD and we also open up GT and we read the lines. And now we go and say the following. For in the range we grab ChrF, then compute and then we pass in translation with the ground truth. Here is the ground truth. We just double check this is the hypothesis, this is the reference, yes. Okay, this should now work. And then I assume we just grab the results or scores. And let's just append this. And finally, we can just find the average of the scores. So like MP mean of MP as array, scores. Importing numpy here, import numpy exactly. That should be it. If I didn't mess up anything, that's roughly it. So we read this, we grab the lines, 977, we grab the lines here, 977, we go through the lines, we strip. Will stripping work in this case? Okay, let's see scores. Okay, so this one retrieves back the string as opposed to, okay, so it returns back corpus score, actual score. Let me just put the breakpoint here quickly. Actual score. Why would anyone think that actual score should be a string? And then retrieve any. Wow. That's cool. That's fascinating. Stats. What stats? Wait. This is tokenized after all. What? What is going on? The stats are what? Compute segment statistics. Wait. This cannot go like this. Let's enter again. Oops. The format part messes us up. The format part makes it messy. Just exit. Go here. Okay, here we are. Go inside here, enter. Stats gives us a bunch of numbers, and then this one aggregates. Compute the F score, and then retrieve back this one, which just has the name beta plus the word order plus the score. Okay. So we can just grab the thing above is just a name, and we can just extract the score itself. Okay, let's go. So we here need to do the following, call the score. Okay, stop this now. Let's rerun. Run. Hit F5. Scores, here are the scores. Let's go here. Run. Print. 37.15. Is that the same number we got before? 37.15. 37.2, which is pretty much, I guess, the same thing, because they might just be rounding to 1. Okay, so looking good. We now have our custom script to calculate the scores if we need to. Let's see. Generate multi. Let's quickly see again. spBLEU, tokenizer, blah blah blah. Why do we even specify this? I mean this. Okay. Let's go back to BLEU. This is our own implementation, and I need to understand why corpus versus sentence. Corpus BLEU, raw corpus BLEU, sentence BLEU. Corpus, for a corpus against a single or multiple, computes for a corpus against a single or multiple references. We should be using this one. TER, sentence TER. Main. Read the reference. This is just some test that they have. What else do you have here? Main. Okay, we can ignore that. We can just put sentence. Let's just see if we put sentence here, sentence, and then remove one parenthesis and remove the second one. Will this give us the same results? Moment of truth, I do expect it to be equivalent. 37.15, that's it. That's it. Now, the thing I want to understand is just quickly, how is the CLI called here? What makes it possible for us to run? Yeah, okay. My brain is already fried. I have to just try and do Turkish here. So let's keep this as it is. Let's comment it out. Let's define new ones, which are going to be English, Latin, Turkish Latin. Okay, exactly. And here we want to have Turkish Latin as well. And here we want to have Turkish Latin as well. This should work. We should rename these to empty path, and this should just be GT path. Ground truth and machine translated. Let's see what's the score for Turkish. 34. Did we get that same number down below? English Latin Deva. Let's see, for English Latin Turkish, 33.4. Why is there this discrepancy? We got 34, they got 33.4. That's weird. Okay. We need to figure out we've done this. How are the command line utils of spBLEU implemented in Python? Around for now. So just grab this one and put it among the issues. Pending. Okay, these are going to be the steps for the next stream. Go through these and also understand what weights and biases is logging exactly, and a couple other things. Let me quickly just implement the BLEU. ChrF corpus BLEU, tokenize none. Let's try and implement this one. Metric, if we choose BLEU, then we're gonna do, so if metric is BLEU, then do this. Otherwise, if metric plus, then we do this. Else, race not implemented there. Okay, and then here let's replace this with prediction, and let's replace this with ground truth, and then understand append this. We just need to understand why is token I set to none. I have no idea whatsoever, but let's see. So score metric score equals to this, and let's run this. Let's see for BLEU what we get. There is some error inside of the mean. Okay, just a second. Same issue as before. We have to pass in the score. Rerun. Blue score 0. What? Why is this? Run. Enter. Create the blue. Hypothesis. Oh. Again. Corpus blue. We actually need centus blue. Rerun. Get the results. 5.96. That's for Turkish. Let's see whether that result makes sense. So let's go to here, Turkish, blue. We got 5.96. And they get a bunch of different numbers here. I'm not sure how we should interpret these. And here for Hindi, 15.7. And for this one again, 9.6 for Turkish. Yet we get 5.96. Huh. Something is off and we have to understand what. Why tokenize none? And maybe let's just remove it and see whether there is any difference. Rerun. 7.66. A bit higher, but still we get 3 different results depending on whether we run with Python, how we run with Python, or we run over command line. So that's why for the next stream I'm going to take some time and understand how the command line are actually implemented in Python. How can I construct equivalent call in Python, and then we'll take it away from there. There are some other tasks I have standing here. We also can go to the IA presentation here. So that's cool. Okay, guys. Whew, this was a long one since this morning. A bit of a break now for a workout for me, and then I'm gonna continue in 2 hours time, or hour and a half, roughly 8:38, more likely 8:45, and then we're going to past midnight. So that's the plan for the next stream. Follow the updates in the channel here, in Open NLLB, in our Discord, and that's the best place to just keep track of the streams and everything else surrounding the project. Cool, guys. Cheers. See you later. I'm gonna go rest this brain a bit. Bye bye.